Okay, Bismillahirrahmanirrahim. So today we are just going to be starting a new topic that is angle properties of a circle, or in other words, we are just going to go for the circle theorems. So first of all, we have discuss some very basic thing about a circle, and then we are going to go for the circle theorems. Okay, now let's say we have a circle. Yes, Rabia, you have to be tell me what this the line that is started from center to the circumference. It is known as
Radius.
that is the radius of a circle. Yes, Tahur, a line that is started circumference passes from the center and ended at the circumference as well. It is known as yes, Tahur, what it is? Yes, Miran.
Diameter.
It is a
Diameter.
diameter. So a line that is started from the circumference passes from the center and ended at circumference. So this whole line is known as diameter. The relation between the diameter and the radius is the diameter is equal to 2 times r because it is radius, it is radius, it is radius. So r plus r, that will be 2r. In other words, the radius will be the half of diameter. All right. Yes, you have to tell me
Yes.
about thing. If you know that thing, you have to please raise the hand. What it is? It is a line that starts from circumference, ended at circumference, but not passes from the center. Yes, Miran.
A segment
I'm
or
talking about a line.
a chord.
It's a chord. This is a chord.
Chord.
Yes, everyone. Any question up to here?
No, sir.
No, sir.
Okay, if you have a chord, let's say I have to say that it is A and B point. So what it is, this highlighted part. Yes, Miran.
A segment.
Now the highlighted part only. It's just a line. Yes, Rabia.
Sir, is it an arc?
It is the arc. It is the and the length of this one is known as arc length, but it is an arc. Yes, everyone. Any question up to here?
No,
No,
sir.
sir.
Okay. Let's say we have to take another circle. A line that starts from this passes from the center, it is known as diameter. We know that. When we have to draw a diameter, it always divides a circle into two equal parts. So this half circle is known as yes, everyone. This half circle is known as yes, Rabia.
A semicircle?
It's a semicircle. All right. Now let's see. Have to be take a circle again. I'm going to be taking a chord as well. Let's say it is a chord A to B. If it is an arc, so it is the arc length. Yes, can you please tell me what it is? Yes, Beran.
This is a segment.
This is the
Segment.
it is segment. It is a smaller segment, so it is known as minor segment. On the other hand, look for this one. It is a segment as well, but it is a
Major
Major
segment.
segment.
the bigger one. So it is the segment as well, but it is a
Major segment.
It is a major segment. Assalamu alaikum, Fatima.
Assalamualaikum, sir.
Yes, how are you?
I'm good. How are you? Sorry for late joining.
No problem. Okay, so yes, this line, the highlighted line, yes, what it is? I just told you.
An arc.
Arc.
It is an arc. It is a smaller one, so it is
Minor arc.
minor arc. And in the same way, if I'm just going to take a arc, this is an arc as well.
It's going to be major arc.
Yes, it will be the major arc. Okay, now we have to go for something about angle. Now this is a circle. In a circle, we are going to be subtended the angle or making the angle from the segment, from the arc, from the chord. Let's say it is a chord. It is a chord, it is A to B. I'm going to be subtending an angle from here on the circumference. And I'm going to be subtending an angle on the center as well. Right? This is the angle, this is the angle. The both angles are subtended angles. Both angles are
Angle.
it is x and x and y. X and y are subtended angle from it is from arc AB means minor arc AB. It is from segment AB, or in other words, it is from chord AB. Right? All of these things are exactly same. Mostly we are going to be using the word the segment. It is subtended angle from the segment AB. Yes, Safa?
Sir, what do you mean by subtended?
Subtended means it is going to be making the angle from here, from these 2 points. Obviously, if you have a chord, so it has 2 points. So we are subtended the angle from here. In other words, if you say that you have a segment, so segment also have 2 points. This one and this one means this is a segment. So
Okay,
you are
sir.
making the angle from there. So in mathematical terminology, we have to say that it is a subtended angle. Clear?
Yes, sir.
Yes, sir.
The angle from arc AB, chord AB, or mostly that we have to use the segment AB. All right. Obviously, if we are talking about arc means minor arc, it is not subtended from the major arc because major arc is here. It is subtended from towards the minor arc in the same way from this chord. All right. So now look at here. One is on the circumference and one is on the center. So angle X is on circumference. So it is known as circumference angle or circum angle. On the other hand, we have the angle Y in this shape. The angle Y is on center. It is known as center angle or central angle. So both are subtended angle, but one is on the circumference and one is on the center. So both are subtended. So we have to use this terminology a lot of times. We have to look at here. It is an angle where it is subtended from. So it is subtended from the segment AB. In the same way, for example, if I have to make the angle here. So look at here. This angle is subtended from AB as well, but it is subtended from the major segment. Clear? It is the subtended angle
Yes.
as well, but it is subtended from the major segments. So obviously they are different. Yes, everyone. Any question up here?
No, sir.
No.
All right. Now we have to be go for the theorem now. All right. So let's see how to go for the first theorem. Okay. The theorem one says that the subtended angle from the same arc, let's say it is the arc AB or the same segment, on center or on circumference. The relation between the angle is the circumference angle is half of central angle, or in other words, the central angle will be the double of or twice of circumference angle. For example, if I have to say that it is angle A, so it will be 2A. It will be the double one, right? In the same way, I'm going to make a circle here. I'm going to be subtending the angle. Just subtended from this arc, right? AB. It is a central angle. It is a circumference angle from the same arc, right? It is a really important thing. Same arc or same segment. So if, for example, it will be A, then circumference angle will be
A over 2.
A by 2. It will be the half of this angle. It is clear?
Yes, sir.
Yes,
Okay.
yes.
We have to understand it. We have to write the observation for this one. So just a second. These are the observations. The observation is if the two angles are being subtended from same arc or same segment, one at the center and one is on the circumference. If you have to look
Circumference.
this thing in the the conclusion is the central angle will be the twice as that of circumference angle, or in other words, the circumference angle will be the half of that central angle. Yes, everyone. Any question in the first theorem?
No,
No,
sir.
sir.
This thing is really important. Okay, because when we have to look for the questions, so it is going to be really difficult to understand it. So we have to be look for the angle that is separated from the same arc. 1 minute. All right, so let's we have to go for the next theorem. Okay, before we have to go for the next theorem, I have to be asked one question. Yes, Safa, can you please tell me if I have to say that this angle is going to be 60 degree, what will be this angle?
Should be half
Sorry,
30.
that will be 30 degree. Yes, Fatima. If I have to say that this angle is going to be, let's say 35 degree, what will be the central angle?
So you add it. So 35 plus 35 will be 70.
Yeah, 70. You can add them or multiply by 2. All right, nice. Okay, now we have the next theorem, that is theorem. The theorem 2 is, for example, if you have a circle and there is a diameter here, it is a diameter. Let's say it is a center. Subtended angle from the diameter or from the semicircle is always equal to, just anyone knows,
90 degree.
90 degree. The subtended angle from the diameter on the circumference that always be equal to 90 degree. It doesn't matter it is going to be where you are going to make it. Let's say we have a circle. I have to take the circle again. I'm going to be just make different. Let's say I have make the angle here. It is separated from diameter, so I'm pretty sure it must be 90 degrees. I'm going to make the central angle here. I'm pretty sure it is 90 degrees. Why? Because this angle is separated from the diameter. Or in other words, it is separated from the semicircle. So that's why this angle is always equal to 90 degrees.
Degree.
Yes, everyone. Theorem 2 is clear?
Yes, sir.
Fair.
All right. So we have to be look for the observations and conclusions there. The observation is angle being subtended by a diameter or a semicircle anywhere on the circumference. We can conclude that the conclusion is the angle will always be not 96, it is 90 degree. Okay?
Yes, sir.
Yes, everyone.
Yes.
Any confusion about theorem 2?
No, sir.
No, sir.
All right. Now let's see how to go for the third theorem. Now we have the third theorem. The third theorem says that the subtended angle, let's say we have the arc, A, B. We have the subtended angle from the arc or segment AB on the circumference. There is another subtended angle on the circumference. there is any other angle from the same segment on the circumference. Yes, what is the relation between them?
They are all same.
They are all going to
Yes.
be same. If it is A, it will be A as well. It is will be A as well. If I have to say that it is 30, so it will be 30 as well. It is 30 as well. But the condition is that must be subtended from same arc. All right, that will not be subtended from the different arcs. Now look at here. It is subtended from the chord AB. But if you had look at carefully, it is from the arc, the major arc AB. So it will never be equal to 30. Right? It is a different one because it is subtended from arc AB, but at this time it is subtended from the major arc. However, the angle A is subtended from the minor arc or a minor segment AB. It is clear?
Yes, sir.
When you are going to be making a conclusion, you have to be look at carefully where the angle is subtended. It is subtended from the major arc or a minor arc. It is major segment or a minor segment. I'm using the both wordings because sometimes examiner use the first one or second one. Sometimes he use say that about segment. Sometimes he says that about the arc. So student can be confused here. Okay, so let's see how to take the observations and the conclusions there. So observation is if you have to see that two or more angles are being subtended by the same arc or same segment on circumference, then the conclusion is angle subtended on the circumference would be same. Yes, everyone. Any question up to here?
No, sir.
No, sir. No, sir.
All right. Before we have to be go for the next theorem, we have a one thing about understand that is cyclic quadrilateral. Yes, anyone knows what is cyclic quadrilateral?
Yes, sir.
What it is?
Sir, all its vertices are on the circumference
No, what is cyclic quadrilateral?
with four sides. Its opposite sides are equal to 180 degree.
Yeah, the sum of the opposite angle in the quadrilateral is equal to 180. Such type of quadrilateral is known as cyclic. Let's say it is the angle A, it is angle B. The sum of the opposite angles is equal to 180 degree. So it is cyclic. Obviously, if it is their sum is going to be 180, so this sum is going to be 180 as well, because we know that the sum of the interior angle of the quadrilateral is always 360. So that will be 180 as well. So a cyclic quadrilateral is a quadrilateral. Let's have to write the definition. If in a quadrilateral, the sum of opposite angle is equal to 180 degree, such type of quadrilateral is known as yes, everyone, it is clear.
Yes, sir.
Okay. Now we have to be go for theorem 4. Okay, now the theorem 4 is same. Yes, Miran, what you say? The theorem,
All of its vertices are on the circumference.
yes. If in a circle you have a quadrilateral inside the circle and all the vertices of the quadrilateral is on the circumference, it doesn't matter where are they. If all the vertices on the circumference, so you are going to be pretty sure this quadrilateral must be cyclic. Means the same condition. If it is angle A, it is angle A, it is angle B, it is angle C, it is angle D. So the sum of the A plus B is equal to 180 degree, or C plus D is equal to 180 degree. Clear?
180.
Yes, sir.
Yes. Yes.
Okay. For example, if I have to say that, yes, Rabia, you have to tell me. If I have to say that this angle is equal to 45 degree, what will be this angle?
It will be 180 minus 45.
That will be
That will be 135.
35 degree. Yes, Safa. If I have to say that this angle is going to be 80 degree, what will be this angle?
100.
That will be 180 minus 80, that will be 100 degree. So let's we have to go for the observations. So the observation is if all the vertices of a quadrilateral are on the circumference of a circle, then we can conclude that the quadrilateral would be cyclic. Cyclic means the sum of the opposite angles will be 180, or obviously we know that if the sum of the two angles is equal to 180, that angles are known as
Elementary.
complementary angles. Yes. Any confusion in theorem 4?
No, sir.
Yes.
All right. Now let's we have to we go for the theorem
5.
5. We have total 8 theorems. Now the theorem 5 is, it is going to be very easy. Let's say you have a circle and there is a line that ties the circle at single point. What it is known as?
Tangent.
It is known as.
Yes, sir.
Tangent.
And if you have to draw a radius, the tangent and the radius are going to meet at single point. Obviously, we know that the tangent is always touches the circle at single point. And if the radius and the tangent are meeting at any same point, so that point must be this one. If the radius and tangent are meeting at the same point, so the angle between the radius and the tangent is always equal to
90 degree.
90 degree. Is clear? It doesn't matter where.
Yes.
Let's say I have to make the circle again. I'm just going to
Sir,
draw a.
is it possible that the tangent and radius are not meeting each other?
Yes, obviously. For example, if you have to make a radius here, there is no angle between the tangent and the radius. Obviously, the two lines are going to make the angle when they are going to meet at the same point. If they are not meeting at the same point, so this means that there is no angle between them. For example, if you had to draw a line here and one line here, they are not meeting. So obviously, if they are not meeting, so there is no angle. It is possible. Okay. So that's why it must be a condition. They must be meted at the same point.
Point.
Obviously, radius will not go outside the circle. Yes, it is
Yes.
clear. All
Yes,
right,
sir.
let's have to draw a tangent here. Okay. Obviously, we have to draw a radius here or here as well. But we are talking about that radius that is going to be meted at the tangent at some point. This is the point. So this angle must be 90 degree. Obviously, in this tangent and in this radius line, they have no relation. So let's we have to be go for the observations and conclusions. So the observation is the radius and the tangent are meeting at the same point. We can conclude that radius and tangent will always be perpendicular.
Perpendicular.
Yes, everyone. Any question about theorem 5?
No, sir.
No, sir.
All right. Now we have the next theorem. Mostly the student will not like this one because most of the time it is going to be difficult to what have to recognize them in the question. It is difficult. We have that is theorem 6.
6.
Okay. First of all, again, we have to take a circle. Okay. And it is this theorem is about tangent as well. And this is the chord. Now, the theorem is if the tangent and the chord meeting at the same point, if the tangent and the chord, obviously the chord can be here. I'm not talking about that chord that are going to be meeting at the tangent with the same point. So the angle between the tangent and the chord is exactly equal to the subtended angle from the same chord on the circumference or same segment from the on the circumference. For example, if I have to say that this is angle A, so this must be angle. It is clear. What I have to say, the angle between the chord and the tangent is exactly equal to the subtended angle from the same chord or from the same segment on the circumference. Yes, everyone, it is clear.
Yes,
Yes,
sir.
sir.
Yes.
For example, if I'm just going to be taking the angle here, so obviously it is going to be new arc, new chord AB, AC. So this is the angle between the tangent and the chord AC. Can anyone tell me what will be the subtended angle from AC on this?
B,
That is angle
B.
B.
B. So let's say I have to give the name B as well. If it angle B, so this will be B as well. So you have to look at carefully. The angle is between which chord and it is subtended from the same chord as well. Then you can compare it. Okay.
Yes, sir.
So if we have a circle here, I'm just going to be making a roughly tangent here. Okay. Draw the chord. Yes, Miran.
Sir, does it have to be a triangle inside the circle or like any shape?
You are talking about this shape?
Yes, sir.
Yes, it is a triangle. No, obviously it's not. If you are talking about angles, so obviously you have to move from the 2 points here to here. Means you are getting two lines, and the one angle that is going to be between these 2 points. If, for example, if I will not make a chord here, so you have the arc, but I have to show the angle, so obviously I will make the line here. In the same way, I have to make the angle, so I will make a line. So it always be a triangle. But you are
Okay,
not pretty sure about anything that what type of angle triangle it is. It is isosceles or equilateral like this.
okay, sir.
Okay, now again I have to be yes, Sahur. Can you please tell me what will be the value of A?
40.
That is 40. It is a tangent and it is the chord. So the angle between the tangent and the chord is 40. So angle A is separated from the same chord, so it is 40 as well. And the B will be 50 degree. Yes, everyone. Theorem 6 is clear?
Yes,
Yes,
sir.
sir. Clear.
Yes, sir.
All right, so we can, the observations and the conclusions are here. So the observation is if the chord and the tangent meeting at the same point, the first thing, angle being separated by the same segment anywhere on the circumference. It is the important thing, not anywhere else. For example, if it is on the central, so obviously this property will not be hold. In the circumference, we can conclude that the angle subtended on the circumference would be same as the angle between the chord and the tangent. Yes, everyone. Any question about theorem 7?
No, sir.
No, sir.
All right. Now let's see how to we go for the second last theorem. It is going to be pretty easy. Theorem 7.
7.
Okay, the theorem 7 says that obviously, first of all, you need a circle. He says that if you have two arcs, let's say I have to draw an arc here and other arc here. We have two arcs. Let's say it is going to be A, B, C, D. So one will be AD and second will be BC. It is the center. It is the center. And these are the midpoints. If it is given that the chord AD and BC are equal, what is given? Let's say I have to write about given by it is given that AD is equal to BC. It is given, so we can conclude that the conclusion is the perpendicular distance from the center of the chord AD and the perpendicular distance from the center to the chord DC, they are equal and they are going to bisect the chord into two equal parts. What it is? It is point P and Q. So OP perpendicularly bisect the chord AD. Here, if you have to take the perpendicular distance from the chord to the center, first of all, obviously it is perpendicular, and second is it is going to be divided a chord into two equal parts. Means AP will be equal to bisect means it is dividing a line into two equal parts, AP is equal to BD. In the same way, for the second thing, you have OQ is perpendicularly
I see.
bisect
BC.
the chord BC. So if this thing is given, we can make a conclusion. And you must be pretty sure it must be a perpendicular distance. Okay? Because obviously we have this distance as well, but it is not a perpendicular. We're not talking about this one. Okay, in this one we have two phases. This is the first phase. If this thing is given, we can, this is the conclusion. And the second thing is, if it is going to be if it is given that the first thing OP is equal to OQ, means the perpendicular distance from the center to the chord are equal. The perpendicular distance OP is perpendicular to AD and OQ is perpendicular to BC. If it is given that OP is equal to OQ and OP is perpendicular to AD as well, means you are taking a perpendicular distance of the chord from the center. If it is given that, so from here you can conclude that, so the conclusion is yes, what is the conclusion? The chords are equal. Okay, it is a reverse thing. We shall look at carefully. If it is given, we can conclude this thing. If the given is the perpendicular distance from the center to the chord, so we can conclude that the chords are equal. Means AD is equal to BC.
Yes, sir, clear.
Yes, everyone. Any question up to here?
No, sir.
No, sir.
You have two ways here. That must be 90 degree, okay? All right, now let's see how do we go for the last property of the circle.
Theorem.
Theorem 8. The first point of the theorem 8 is, there is a lot of points in theorem 8. The first point in the theorem 8 is, if you have a circle and there is any point that is outside the circle, any point that is outside the circle can maximum makes two tangents with the circle. You are not able to make more tangents with this point. So the first thing, if you have any point that is outside the circle, can maximum makes two tangents with a circle. So from a point outside the circle, we can draw maximum two tangents Yes, the first point is clear.
Yes, sir.
sir.
The second point is, let's say this is the point. Obviously, he's going to be beat at the circle. So let's say this is the point A and it is the point B. So the second point is the distance from the point P to this point A is always equal to from P to P. Meaning the distance from the point to this, the point between the tangent and the circumference is always equal to the point and between the circumference and a tangent. They are exactly equal. PA is equal to PP. Yes, everyone. Any question up here?
No,
Sir,
sir.
okay, the second one again. The second one.
The second one says that obviously, first of all, we have make a maximum two tangents. The property
Yes,
is these tangents are equal. Means PA is equal to PB.
PV.
For example, if you have to get that the length AP is equal to 5 centimeter, so I must be pretty sure the PB must be equal to
5
centimeter.
centimeters.
as well. Clear?
Yes, sir. Clear.
Well, let's I have to let's say this is the center. I'm going to be make these points with the center, and we know that it is a center, and it is a radius, and it is a tangent. And in the previous
Yes,
property, we have learned that the angle between the tangent
is 90 degree.
and the radius always equal to
90 degrees.
90 degrees. After meeting these two lines, we are going to be get a shape, and it is a quadrilateral. What it is?
Quadrilateral.
But it is not a simple one. It is a specific type of quadrilateral. The first property of this quadrilateral is it is cyclic because the sum of these two angles must be 180. So I'm going to be pretty sure the sum of these two angles will be 180 as well. Let's say this is angle
Oh, yes, sir.
A and this is angle B. So their sum must be 180 degree as well. So this means that the first property of this quadrilateral is cyclic. The second one, it is a kite shape. It is a kite shape.
Kite.
If we call the properties that we have done, the adjacent sides are equal, right? So we know that it
Yes,
is
sir.
AP and BP are equal from the second point. A, it is O. So A to O and O to B are equal because they are radius. So they are going to be making a kite shape as well. So the third point is we have OAPB. OAPB is a special type of quadrilateral. And what is special in it? The first thing, it is cyclic quadrilateral. The second thing is it is a kite shape. Clear?
Yes, sir.
Yes, sir.
Yes, Mehran, Safa, Fatima.
Yes,
Yes,
sir. It's
sir.
clear.
All right. And obviously, we have to say that it is a cyclic. If it is cyclic, so this means that the sum of opposite angle are will be 180. So it is 90, 90, it is 180. And the second one is A plus B will be 180 degree as well. It is a property. Obviously, sometimes it's not going to give you any angle during the question. So you must be pretty sure it is 90 and it is the sum of these two must be 180 degree.
Clear, sir.
And the last thing is we did not turn that topic, but I just tell you if you are going to be draw a diagonal, how to draw a diagonal. We know that the diagonals always going to be in this diagonal between the adjacent sides. It always divides the angle into two equal parts.
Equal parts, yes, sir.
Means this angle, it is a by 2, and this angle will be a by 2 as well. So you are going to be get two triangles. You are getting two triangles, OBP and OAP. And the same thing is these two triangles are congruent, means exactly equal. But in mathematics, we have to say that they are congruent. Why? Because OP is the same length, BP, PA and PB are equal as well. OB and OA are equal as well because they are radius. So look at here, these two triangles are exactly same. So we have to say that what is triangle? OAP and OBB. O triangle OAP is congruent to, this is the sign of for congruency. We have to make three lines. OAP is congruent to OBP. Clear? Yes, Fatima.
So if we have time, can you explain me question 18 from the previous worksheet that you sent in the group chat?
Question 18.
Yeah, from the worksheet I
All right.
asked you in
Okay,
the
okay.
group chat.
Okay. Yes, in this angle in circle theorems, you have any question, everyone?
No, sir.
No, sir.
Clear.
All right. Now, before the next class, means we have a class tomorrow. Before the next class, you have to be, first of all, you have to the best understanding of these proper theorems, and you have to memorize it. Okay, because there is a lot of things that you need to be memorized. Okay, what are the properties? Are the theorems? So you have to memorize it before the next class. So in the next class, we have a practice session about this one, and we are just going to be close this topic. Okay.
Okay, sir.
Yes, sir.